In this lesson, we're going to cover some additional BGP configuration options that Arista provides, with the BGP timers, the use of BFD, and the option to use a password. We can leverage these features to tweak our BGP configuration to meet the dynamic requirements that often come up with pushing packets around from A to B. The first topic to review is timers. By default, the Arista BGP implementation sets our neighbor keep alive timer to 60 seconds and a default hold time, otherwise considered the dead timer, of 180 seconds. In some situations, that time is entirely too long to wait for the detection of a failure and then to make a routing decision to get around the issue. We have a couple of ways that we can reduce these timers. We can do it for all the BGP neighbors with the BGP configuration of config router BGP 65001 and then timers ? And we see we need the keyword BGP space ? And then we have our keep alive interval. For instance, let's put in 3 ? And then we see we have a hold time. In this example, we could do 9. Now that's helpful if we only have one neighbor or a few neighbors, and all of them can support these dialed down timers. If we need to be more specific and associate custom timers to a specific peer, we can do that with the command neighbor 172.16.200.2 timers ? And then here you can see we have our keep alive interval, and then it'll be our hold time. And we can also associate the timer option with the specific BGP peer group. Then any neighbor that's tied to that BGP peer group will inherit the custom timers. On switch 1 in our lab, we had done that with another BGP peer group, and we can see that with show run section router BGP. And under our example 1 peer group, we had assigned timers of 1 and 3, so that all neighbors that tied to the peer group example 1 will use their BGP timers of 1 and 3. In some instances, like connecting to internet service providers, the ISP won't agree to dial down the BGP timers so aggressively, and this is understandable, as the ISP router may have hundreds of BGP neighbors, and aggressive timers may be too much of a burden on those devices. This is an example where BFD comes in handy. BFD, or bidirectional forwarding detection, is a monitoring solution that allows us to use very aggressive timers to monitor the reachability of a device outside of BGP, but that BGP can subscribe to, therefore allowing for much faster detection of neighbor loss than the default of 180 seconds. First, we configure BFD on the interfaces that connect to the neighboring BGP devices. Let's turn on BFD between switch 1 and switch 3 of our lab. On switch 1, let's verify where switch 3 is connected. One way we could do that is with the show LLDP neighbors command. Here we can see that it's Ethernet 3 that connects us to switch 3. Show run interface Ethernet 3. Now let's add the BFD configuration. Config interface Ethernet 3, enter, and then BFD ? And we can see we have an interval to set the transmit rate in milliseconds. Interval ? And now this is the rate in seconds that we will be sending our BFD packets. Here we'll put in 200 ? And now min_rx, or minimum receive, which sets the expected minimum incoming rate also in milliseconds. So we'll put that at 200 as well. Space ? And now we have a multiplier. And this multiplier is what allows us to determine what the dead interval is. So here, that can be in the range of 3 to 50. So let's put in 3 and then enter. And now verification, show run interface Ethernet 3. And we can see our BFD configuration there under interface Ethernet 3's configuration. And then we could issue the command show BFD neighbors, enter. And here we can see we don't yet have a neighbor. So now we move over to switch 3 to enable BFD there. And exit SSH over to switch 3. Here again, do the show LLDP neighbor to verify where we're connected to switch 1. And we see that's on interface Ethernet 3. Config, enter, interface Ethernet 3, enter. and then the same configuration, BFD interval 200, and then min underscore receive or min underscore RX, and again 200, and then our multiplier, which will be 3. And verification, show run interface Ethernet 3. And then now show BFD neighbors, enter. And we still don't have a neighbor. We need to subscribe BGP to the BFD information. So here on switch 3, that's router BGP 65003. And then we do that via neighbor command, neighbor 172.16.200.1, and then a question mark. And in the output, you can see fallover is where we configure the BFD protocol options for this specific peer. Fall over, question mark, and then BFD, enter. And now if we do a show run section, router BGP for verification, we can see that our 200.1 neighbor is going to be using the fallover of subscribing to BFD. Now if we issue the command show BFD neighbors, we see we do have a neighbor, yet right now the state is down. So we need to jump back over to switch 1 to configure its BGP to use BFD as well. And exit SSH to switch 1, config router BGP 65001, enter, and then neighbor. And over here we had peer groups. So we're going to put this under example 1, fallover, and then BFD, enter. And verification, show run section router BGP. And now under the example 1 peer group, we see anybody associated to that peer group will use the fallover method of BFD. And now if we enter the command show BFD neighbors, we actually have full output where we see the destination address, the interface we're using, and the state. And now our state is up. And the last topic for this section is the BGP neighbor authentication option. Arista allows us to authenticate a peer by adding a password to the neighbor statement in BGP router configuration mode. The command to add the password to authenticate a neighbor is neighbor password, and then we can see that we can enter a password. Let's do this with the example 1 peer group so that we add authentication between switch 1 and switch 3. Neighbor example 1 space password question mark, and then we can enter our password. So here I'll just put in BGP secret, enter. And verification with show run section router BGP. And now we can see under the example 1 peer group, anybody tied to that peer group will use a password to validate a peer. If I issue the show IP BGP summary command now, we can see that where I had 2 neighbors, I've actually lost one. I'm down to just 1 neighbor. Let's check the logging, see if it tells us what happened. Show logging, pipe, grep, -I to ignore case, and then BGP. And then in the output, we can see exactly why we lost the neighbor. No MD5 digest from 172.16.200.2. Let's jump over to switch 3 and get it back. End, exit, over to switch 3, enable config router BGP 65003, and then here the command is neighbor 172.16.200.1 password, and then our password BGP secret, enter. Verification, show run section router BGP. We can see now with the neighbor 200.1, we have a password to be used. If we issue the command show IP BGP summary, we can see that we are now starting to establish our BGP relationship again. And we can look at it specifically with show IP BGP neighbor 172.16.200.1. And in this output, we can see that we now have our neighbor established and that we're configured to use a password to establish a relationship with that neighbor. And that can be seen here. MD5 authentication is enabled. In this lesson, we played around with timers, BFD, bidirectional forwarding detection, and setting a password on the BGP neighbor relationship. And those are only a few examples of the tweaks that we have available to us in Arista's implementation of BGP.